It's not a game, it's a rich thing.
Sun is older than the Earth, but the water you drink is older than the sun. Consider this the next time you pick up a fresh glass of water. Some of the molecules in that water are billions of years old, much older than the solar system itself. This seems impossible at first. How could water on Earth predate the solar system in which it exists? However, recent peer-reviewed research published in the journal Science confirms this. Astronomers arrived at this conclusion by proving that water in our solar system had to have been produced inside the thick cloud of gas and dust that preceded and was required for the formation of the star we know as the Sun. This means that the water that finally made its way to Earth through wet rocks, such as asteroids or comets, existed before the Sun exploded into a star. Ted Bergen, an astronomy professor at the University of Michigan in Ann Arbor and one of the study's authors, describes the discovery as extraordinary. If you look back 4.6 billion years ago, there's an incredible story to be told, he says. Earth was formed from microscopic particles little larger than the width of a human hair. Astronomers, who, Bergen says, are very imaginative souls, call this dust. These dust particles would collect so much energy from the sun at their distance from it that they would become too hot for water to condense on them as ice. This means that when the Earth was born, it was dry, Bergen says. So that's an interesting problem. Where did the water come from? If we consider the matter more generally, Bergen asserts, we must ask, where did all the water in the cosmos originate from? The universe isn't made of water, it's made of atoms, he explains. So, at some place, at some time, those atoms came together in the universe, via chemistry, to form water. Fortunately, astronomers can investigate that chemistry in Earth-based laboratories. They are capable of reproducing the circumstances that result in the formation of water. They do this using a process known as isotopic fingerprinting. The second kind is deuterium. These elements coexist in a more or less stable ratio throughout the solar system. For every deuterium atom, there are around 100,000 hydrogen atoms. Water has around this amount of hydrogen and deuterium. But chemistry tells us that under very specific conditions there can be in excess of deuterium, says Bergen. That's what we call an isotopic fingerprint. Earth contains a surplus of deuterium, as do comets and asteroids. The isotopic fingerprint appears only at very low temperatures, between 10 and 20 degrees above absolute zero, minus 441 degrees Fahrenheit. So, because the Earth has this excess of deuterium, Bergen explains, we know one thing already. That whatever the source of the water was, it was really, really cold. So now we have to look at star and planet formation and ask, where is it at cold? When a star starts to develop, temperatures may get so low in just two locations inside the enormous violent system, within the cloud of gas and dust that surrounds the protostar, or within the accretion disk that begins to form around it. However, there is one more twist. Water is also created by a chemical process called ionization. The researchers established that the disk is incapable of powering this chemical reaction by examining a comprehensive model of it. This tells you that, of the two potential sources to make the water, the disk and the cloud of gas and dust, the disk can't do it, Bergen explains. Therefore, the water with the isotopic fingerprint could only have emerged from the gas and dust about 1 million years before the formation of the Sun. Nonetheless, this begs the issue of how this water reached Earth. According to Bergen, planets are generated from the same cloud of gas and dust that collapses and ignites to form a star. Within the cloud, rocks were thrown into space and collided with the particles that eventually created Earth. Although some of them lacked water, they collided with the Earth and amalgamated with it. Additional boulders were flung our way from a greater distance, and these rocks were chilly enough to contain water. So as the Earth was being born, these rocks from greater distances supplied the water, Bergen says. The water became part of the rocks, and it just outgassed via volcanoes, and that created the oceans and the atmosphere. and this wonderful planet that we have today.